Welcome back to Math 109 Plane Trigonometry. In this video, we're going to take a look at how to derive the law of cosines, which we'll be using to solve side angles side and side triangles. So we'll start by drawing a coordinate plane. Then we're going to orient a generic triangle, ABC, such that the angle B is located at the origin. The angle C is on the positive x-axis. And the angle A, in this case, I'm going to draw in the second quadrant, but it could also be in the first quadrant. So we draw this triangle, and we'll label the side lengths as we normally do, opposite of the given angle. But we'll notice that C is going to be the R that we had in the definition of sine and cosine, because it is a line extending from the origin to the point A. So that would be angle B, so we can say that the sine of B is equal to the x-coordinate of A, which we're going to call y, over C. And then by extension, C times the sine of B is equal to y. Furthermore, we know the cosine of B is equal to x over C. So we get C cosine of B is equal to x. So now we're going to apply the distance formula. So we know the point A is C cosine B, C sine B. And then we know that the length, and I put these down incorrectly, I'll go ahead and fix that. A should be opposite of angle A, and B should be opposite of angle B. So now the point C is going to be A units away from the origin along the positive x-axis, so it has as the point A0. So now we're going to find the distance between the points A and C as we've drawn the triangle. That is length B. So we'll apply the distance formula. So that's the square root of C cosine B minus A squared plus C sine B minus 0 squared. And in this case, we don't want to be messing around with that square root. We're going to go ahead and square both sides to get B squared is equal to C cosine B minus A squared plus C sine B, or C squared sine squared B. I went ahead and applied the squaring there as well. So now I'll go ahead and expand that C cosine B minus A squared. So I get B squared is equal to C squared cosine squared B minus 2 AC cosine B plus A squared, and then we still have plus C squared sine squared B. Now I'm going to do a little bit of rearranging with this. And basically the order I'm putting this in will be standard order that you'll usually see in the law of cosines written in. I'll go A squared plus C squared cosine squared b plus c squared sine squared b minus 2ac cosine b. Well, now we have these two terms with c squared in them. I'm going to go ahead and factor out a c squared from them and combine them. So we get b squared is equal to a squared plus c squared multiplied by the quantity cosine squared b plus sine squared b minus 2ac cosine b. Now the reason for that clever factoring is we know cosine squared b plus sine squared b is equal to 1. So we get b squared is equal to a squared plus c squared minus 2ac cosine b. So that is one form of the law of cosines. There's a couple of different forms that we can look at with this because of the fact we can simply relabel points or put a different point at the origin. So in the end, the three forms of the law of cosines we have would be b squared equals a squared plus c squared minus 2ac cosine b. A squared is equal to b squared plus c squared minus 2bc cosine of a. And then the form that I have it memorized in, which may seem familiar to some extent, c squared is equal to a squared plus b squared minus 2ab cosine of c. Which, if the cosine of c is 0, which would be the case for a 90-degree angle, then we get c squared equals a squared plus b squared, which is the Pythagorean theorem. So you can almost look at the law of cosines as being a generalization of the Pythagorean theorem to any triangle. So that's going to do it for this video. In the next couple of videos, we're going to take a look at examples of solving triangles using the law of cosines.